Hello everyone, I am Dr. Satyapriya, Assistant Professor in the Department of Computer Science at St. Joseph College. Today we will be discussing an important topic in Android development, that is screen layout design. As you all know, the user interface plays a major role in how users interact with an application. A well-structured layout makes the application visually appealing, easy to navigate, and efficient. In this session, we will explore how Android organizes UI elements using views and view groups, the different types of layouts available, and how we can create a well-structured UI using XML and Java. By the end of the session, you will have a strong understanding of how to design efficient and interactive layout for your Android application. Let's begin the session by introducing screen layout design. So what exactly screen layout design is? It is the process of arranging UI elements on the screen in structured way so that users can interact with the application easily. UI is the backbone of any application. The popular applications that have good UI are Instagram, YouTube, and Uber. To design good UI, two major classes are used, that are views and view groups. Let's understand this concept with simple example. Imagine designing a house. You need to place doors, windows, furnitures in the right places for a smooth experience. Similarly, in Android, we place UI components like buttons, text fields, and images in well-organized manners. So, good UI is not just about looks, it impacts user experience, performance, and usability. Android provides different layer structures to help developers arrange UI components effectively. Okay, and today we will explore them in detail. In Android, the user interface is structured like a tree hierarchy where every element on the screen is either a view or a view group. Understanding this hierarchy is essential for designing efficient and scalable applications. What is a view in Android? In Android, every UI element that the user interacts with is derived from the view class. A view represents a rectangular section on the screen where content is displayed. Every UI element is a subclass of a view here. Think about the Facebook like button. It is a UI element that the user taps to like a post. This button is actually a subclass of the view class. It has properties like a size, position, color, and click behavior, all managed by the view class only. Then every view object in Android has a set of attributes that control how it looks and behaves on the screen. These attributes determine the size, position, interaction, and display order of UI elements. Key attributes of view classes are size measurements, positioning, Z order, scrolling behavior, user interaction. Size and measurements means it defines the height and width of the view in pixel or dp or match parent or wrap content. Positioning determines alignment on the screen like left, right, center, top or bottom. Z order controls the stacking order of views, which means elements appear on top when overlapping. Scrolling behavior enables scrolling inside views like a list view or text area. User interaction handles gesture, clicks, focus, and keystrokes. So these are the major key attributes of a view class. So let's understand this concept with an example. Imagine you are using Google Maps to search for a restaurant. The map view adjusts its size to fit your screen. Your location is pinned at the correct spot, and when you zoom or scroll, the map smoothly responds. Each of these interaction is controlled by attributes of the view class only. Then what is a view group in Android? In Android, UI elements are rarely placed individually. Instead, they are organized inside view groups, which act as containers to hold multiple views objects. These view groups help structure their layout in a logical manner. There are different types of view groups are available. that are linear layout, relative layout, constraint layout, and frame layout. Linear layout arranges a views in a single row or column. It means horizontal or vertical. And relative layout positions the views relative to each other or parent container. Constraint layout, a flexible layout that allows complex positioning using constraints. Frame layout is a simple layout where views overlap on top each other. Let's take a real world example to understand how view groups organize multiple UI elements in an Android application. One of the best example is the YouTube video player. How YouTube video player uses view groups. Frame layout uses the video player uses a frame layout to overlap play or pause buttons, progress bar, and subtitles over the video. The title, channel name, and subscribe button are arranged in a vertical list using linear layout. The video suggestion section is placed below the video using relative layout, aligning each item with the thumbnails and next. The floating mini player is managed using constraint layout, keeping the video and controls positioned properly. When you watch a video, the player controls appear on the top, the title and like button are structured below, and suggested video are aligned in a list. This organized UI is possible because of different view groups working together. Same like that, another one example for understanding the view groups concept. Consider an calculator application. Here, each button like 0 to 9 plus minus division equal to as a separate view. It's responding to user input. The entire keypad 0 to 9 and operators are placed inside a view group which aligns the button in a row and columns. Every screen in an Android application is structured using views and view groups only. These elements define the UI layout and how users interact with the application. To build UI with the views and view groups, XML is used to define layouts easily without writing Java or Kotlin code. Java or Kotlin is used to handle user interaction like clicks, gesture, and keyboard inputs. Let's take a real-time example of how view and view group work together in a popular application, Facebook login screen. How Facebook login screen uses view and view groups. Linear layout, it uses to entire login screen is arranged in a vertical order like a logo, email field, password field, login button, sign up link. Image view used to place the logo at the top is a view that displays an image. Edit text used to put input fields like views, username, password. These are views that allow user to enter text. And then button is for login. It's another view that handles the click interaction. And then text view. These are views like the text views here or forgot password, create account. It placed at bottom for user and actions. And relative layout, it's for aligning elements. It ensures a proper placement of UI elements on different screen sizes. When a user enters their email and password in the edit text fields and taps the login button, the Java or Kotlin code processes the input and logs the user in. If incorrect, a text view message appears showing an error. Now let's understand the role of XML in UI design. In Android development, XML plays a crucial role in defining UI layouts. It allows us to design screen without Java or Kotlin code. Why we need to XML for UI design? There are different features or separation of design and logic, faster UI development, easy maintenance and update, scalability. Separation of design and logic means UI design is in XML while functionality is handled in Java or Kotlin. No, we don't need to write Java code for every UI element manually. That's why it's very faster for UI development. And making changes in XML doesn't affect the backend code. So maintenance and updation is very easy here. And it works well with the different screen sizes and orientation. That's why it's very scalability. Views events handling is very important in Android development. In Android application, user interaction are handled through event listeners. Views can detect and respond various users like clicks, gesture, and scrolling. Types of user interactions: button clicks, keystrokes, gestures, scrolling. If suppose we click a submit button in a login form, it's called button clicks. And then typing a message in WhatsApp, it's a keystrokes. Swiping through Instagram stories is a gesture. Scrolling through a YouTube video playlist is a scrolling. Consider an example of Instagram. When a user swipes left or right on a story, the app detects the gesture and moves to next or previous story seamlessly. So this is an example for user interaction of views. How view groups are organized and maintained in Android application. Every UI element is arranged within a view group, which helps in structuring and organizing views properly. There are two kind of view groups: parent view groups, child view groups. Parent view groups can contain multiple child groups or views. Consider an example e-commerce application like Amazon, Flipkart. Here, parent view group is constraint layout, and child view groups is a recycler view for product list, card view for individual items. And then the differences between views and view groups are: view is a single UI element. View groups is a container for a multiple views. It contains a multiple views on a single layout. The best example for view is button or text view or edit text, etc. View groups example: linear layout, relative layout, frame layout, etc. View contain other elements? No, but view groups contain other elements like button, text, edit text, etc. Mainly view used for displaying UI elements, but view groups used for arranging UI elements. The next topic is nesting views. Nesting views in Android, it's a layout that contain other nested layers to create more complex and structured interfaces. Nesting helps in better organization and flexibility when designing application screens. How nested layers will be: parent layout, child layout, proper closing tags. Parent layout holds the multiple child layers and UI elements. Child layout defines section inside the parent layout that allows better alignment. Proper closing tags, XML tags, must be closed in the correct order for the layout to work properly. Consider an example login screen. Here we have a vertical linear layout and a horizontal linear layout. In vertical linear layout, it contains text view, two edit box fields for username and password, and nested horizontal linear layout for the login and cancel buttons. These structures ensure a clean and organized UI. So this is called nested layout. It's mostly used for a more complex application only. Thank you. I hope you have understood the concept clearly. If you have any doubt, you can ask. Thank you for your attention.